Are we live? We're live. Okay, cool. So we will continue. We will continue. Failed to prepare block. Are you freaking kidding me? You cannot be for real. It's become a bit buggy since the last release, so I have to go and check. Maybe I'll just go narrow. I did a bunch of changes, but it's just slower now. I did a bunch of changes yesterday in terms of how this goes, how this works. So, yeah, we did this notebook, short duration, we did this. So we're just marking. So now we have an I'm done answering button. I kind of like changed. I think this, I was looking for this kind of, I was looking for something a bit easier to understand in terms of the just spoken part of it, because let's just do and now none of them has a DAC actually. This is not good. Now none of them has a DAC, but it's okay. It's okay. We can, I mean, let me document this. None of them has a DAC now. Sorry guys. Okay, but we're gonna be doing. So what about we do probe perception, recognition densities, beliefs without yet changing the world, and what role do prediction errors play in the update story? Probe perception, how does minimizing free energy? I mean, let's dive into this. How does minimizing free energy change recognition densities, beliefs? This is stupid. Hunt for answers. It's like I almost feel like I added this, but like, because I still need to convey to the user that it's like the whole point of this is remove this. The whole point of these is you're supposed to hunt for answers, right? That's something that I haven't gotten yet the harness to be able to, like, from a policy perspective, tell you. I don't want to do built-in browser because this is technically a fucking mess. Anyway, probe perception, how does minimizing free energy change recognition densities? What are recognition densities? Maybe one thing that I can do is actually just a kind of a bit of as a wild thing here. Recognition densities. Maybe I can have a layer. I'm just talking a lot now. Maybe I just have a layer that takes a look at the the probe and actually highlights concepts that could be that you can go and hunt for. Right? I don't want the AI to give you the definition. You have to go and hunt for them. Like you know what I mean? I'll go here basically. Grokpedia. Maybe that's what it should actually do, you know? Yeah, maybe. Probe perception. So with recognition densities, let's go. Maybe, give me a second. Maybe actually this should be Grokipedia. Yeah, why not actually? Add Grokipedia helper. Basically highlight concepts on the text that you can click and it opens Grok tool. Like that's but the thing is, I want the person, like the person has to be aware. We're basically building behavior. That's the point of the harness, right? So I want these like recognition densities, for example. I don't know why, like recognition densities and beliefs, like what are recognition densities, right? So it blocked the pop-up, brother. Did it? Always allow. There we go. What are recognition densities? Beautiful. Why doesn't this open now? Okay. And I'm gonna add here, I'm done answering actually. Yeah, definitely. What else do we have here? So we have minimizing free energy, change recognition densities, beliefs without changing the world, yet changing the world. And what role do prediction errors play? It's minimizing. So inference framework primarily associated with confidence and quality. Recognition densities is a core technical term. Okay, so now okay, so it refers to the approximate variational posterior density over hidden causes. It refers to the approximate variational posterior density over hidden causes, states, or parameters, given sensory observations of data. This density encodes an agent's or the brain's probabilistic beliefs. Okay, so there's a lot of technical terms here. The density encodes an agent's. First of all, why are we using the term density? By the way, these should also have the autostage, actually. I just realized that the peak and peak, small things like these, that's why testing is important. The peak and peak should also show the autostage bar. Because that's actually, it's happening anyway, right? Yeah, anyway. Cool. So this is an important aspect of these. I need to highlight these so that you are able to just click and open the Grok tool. Or even Dante's, right? But Dante's is more like a specific here. So maybe we can just Dante's or Grok. It's more structured. Anyway, where are we? Wisdom density, because recognition density is a probability density function. I forgot what those were. Forgot what. Can you give me a refresher? That's how I learn, by the way. I'm testing the framework right now, but like I'm testing the harness, but that's the whole point. Okay. So the core idea of a probability density for a continuous random variable is a function that tells you how the probability is spread out along the real line or higher dimensional space. The actual probability that x falls inside an interval is given by the area under the curve of the density function. Oh, so it's just it's just the typical visualization that you have of a probability function, right? Yeah, the probability. Discrete case, discrete coin flips use the probability mass function. The value px is the probability of that exact outcome. Individual points have probability 0. Probability only makes sense over intervals, hence we need a density. Okay. Why this matters for recognition densities? In the free energy principle, recognition density is exactly a PDF of the continuous space of possible hidden causes and states. When the free energy functional takes the expectation, it is integrating with respect to this density. That's a refresher. So, okay, so we're talking about the posterior density. So recognition densities. Overheating causes states or parameters given sensory. This density encodes an agent's probabilistic beliefs or best guess about the external or generative causes of the sensory input. It is sometimes also called variational density or R density. So recognition densities. But wouldn't it be then from the prior? So it states parameters given sufficient story, density encodes an agent's. Wouldn't it then be from a prior? It refers to the approximate variational posterior density, not prior density. Wouldn't it refer to the prior density, not posterior? Isn't the posterior after? I'm very likely mixing up a lot of terms here, guys, so don't get too. The prior is the belief about causes before seeing the data. Okay, so you're seeing the data and it's more, okay, so generative density, likelihood, how causes produce observations, the true belief about causes after seeing the data. Recognition density is the variation approximation of the posterior. Oh, okay. It's not that easy. It's the approximate posterior, not the prior. The recognition density. So it's approximation to the posterior. The recognition density is optimized by minimizing free energy so that it becomes as close as possible to the true posterior. Oh, so the recognition density and the true posterior is the surprise. So the difference so to say. So the recognition density is what the agent actually maintains and optimizes, right? Okay, so the recognition density is what the agent thinks will happen. So that's wrong. So what I just said here is wrong. So the recognition density, okay, so the recognition density, the recognition, how does minimizing free energy change recognition densities without yet changing the world, and what role do prediction errors play in that update story? My guess here is that prediction errors inform the way that you want to modify the recognition density. But this didn't submit. Oh no, it actually did. Okay. It did, but it cleared it out. Okay, so when I'm done answering, give me a second. When the UI, this is So recognition density is the agent's approximate posterior over hidden causes given sensations, not the prior and not the true posterior. Minimizing free energy tunes the density so it hacks the true posterior. It hacks the true posterior as close to the variational, while the world and the generative model stay fixed. Prediction errors drive the update. They are the mismatch between what the current recognition density predicts and what actually arrived. Those errors reshape the recognition density until expected energy and complexity balance and free energy drops. Practice step in the notebook, write 4 or 5 lines. Write 4 or 5 lines for the one cost toy setup. What cues before versus after free energy step? What stays fixed in the world? Where prediction? I'm not ready yet for that. Wait a second. So recognition density is the agent's approximate posterior over hidden causes given sensations. Not the posterior, not the true posterior. Minimizing free energy tunes that density. So it hacks the true posterior. Minimizing free energy tunes that density. So it hacks the posterior as close as the variational family allows. Whatever that means. Right? While the world and the generative model stay fixed. Now, question then. How can the generative model stay fixed? If we update the recognition density, how can the gen model stay fixed? Like the recognition density is something that depends on the gen model, isn't it? I mean, I thought that was the whole point. The generative model, if you don't change the generative model, how can you even change the recognition density? Because like you cannot have the same generative model about the world, but then at the same time sort of change what you expect to happen. You know what I mean? I'm almost thinking like this preview makes no sense. I think we can get rid of these. See recent thoughts. Only Eiley, because tap is a different thing. Okay. So good question. This is one of subtle but crucial points. The recognition density and the generative model are coupled through the free energy functional, but they are still independent objects that can be updated on different timescales. How is that? How? Fuck, what did I do? Sorry, I clicked the wrong mouse button. No, I had a good answer. Maybe I can just look at the history. There you go. Here you go. Good question. This is one of the... Okay, so recognition density and the generative model are coupled through the free energy functional. Free energy is a functional of both. Okay, so if free energy is a functional of both, and remind me what was a functional? So if free energy is basically a function of both or a function of both, then I get it. Then I guess free energy is the relationship, and so okay, so a functional is a function of functions. Okay, yeah, I guess that's what it is. And it returns a scalar. Okay. Alrighty. So yes. So essentially, it's a function of both. So generative density or generative model parameters is held fixed. We are free to change the recognition density, and that's free energy. So okay. So at an object level or at an agent level, what objects are we holding that make up this model? Gen model plus recognition density plus what else? So free energy is a functional, mathematically speaking, between the two things. That's good. And I guess what I have to do here is, and I do not have to complete this, by the way. I can just move on to other stuff, right? Guess right. Here is right. The prediction errors. Try this. In the notebook, write 4-6 lines for the one Costway setup. We'll pressure test it. So fixing the wall. Generative model recognition density. Everything else, policies, expected free energy, hierarchical levels, precision weightings, is built on top of the core pair. So what about, okay, so what about the following? And by the way, this is, I think that definitely needs to be fixed. This is actually weird. The peak in peak needs to be redesigned. This is actually useless. It's useless completely. Because I'm seeing kind of like something like that's weird. All right. Yeah, mismatch between what the current recognition density predicts what actually trying. Like I'm still trying to figure this out. So let me ask another question. Is there a universal is there a universal formulation of the free energy exponent functional, or is it essentially the free energy functional something that can be native to the agent as well? Like the actual relationship, right? I guess the free energy, I guess for some agents, minimizing free energy, the free energy functional is easier than for others. There's a universal mathematical form of information energy, but the concrete functional that any particular agent is minimizing is native to that agent. Abstract structure, okay. Hmm. Okay. Plugged into the universal expression. The generative model. Yeah, okay, so I guess what okay, so the relationship is fixed. What changes is the generative model. Okay, but if so, if what yeah, okay, so if what changes is the generative model and the form of recognition density, I guess you can build even a crazier mathematical structure or concept where essentially you're saying like configuration space is probably AGI, or like how humanity actually is like humanity's intelligence. Like the space of all possible generative models and recognition densities. Yeah, I guess so, but that's maybe like out of the whole point here. Okay, anyway, so that's good. So we're learning a bit of the formalism. That's good. I was just thinking about one thing. I was just thinking to add here, like I'm done answering slash um slash rephrase. Maybe not rephrase. I wouldn't say rephrase because rephrase is good. I would just say I'm done answering. Um, I'm thinking whether it makes sense or not. I don't want something that makes it explain or whatever. I don't know. I'm done answering. I guess it's okay. I'm done answering. It's okay. Guys, see you tomorrow. See you tomorrow.